Welcome back, dear students. This is Dr. Biju Vasudevan. In this video, we are going to discuss Calculus 3, Math 211 for week 13, in which the chapter 14.1 double integrals will be discussed. Double integral generally in rectangular regions. This is second section is non-rectangular region. So first part we will discuss our rectangular regions. Okay, here the problem is the volume problem. Given a function f of two variables that is continuous and non-negative on the region on a region or in the xy plane. See, just like we should recall our first integration, the single integration. When there is a function f of x, if you integrate from a to b, you are finding the area below the curve above the x-axis between a and b, isn't it? So here in double integration is iterative integrations. We will integrate a function twice with the different variables. So two integrations in iterative order. So that's what we are going to do here. What's the find the volume? So here you are by single integration you are finding the area. By double integration you are finding the volume. So this is the surface of the function given as z is equal to f of xy. So for this surface function, maybe there is any function, isn't it? This is the region given on the xy plane. This is the region given on the xy plane. So this surface function is openly larger, isn't it? Anywhere available. We are integrating this function only in this part. This part is the part above the given region, isn't it, on the surface. So when you integrate the function only in this region, the region is given on the xy plane, then we are finding the volume of this shape. The formula can be derived just like our Riemann sum that we have used for a single integration. We divide this region into n parts, take one part, find its area. We call it area as del ak, small area, isn't it? We figure out a point there, xk star, yk star, and find the height at this point f. When you substitute this xy in this function, you will find the height, which is f of xk star, yk star. So when you multiply area with the height, you get volume. That is for the small part. And when you sum this volume for n parts, you get summation of f of xk star, yk star, the height, and the del ak. And when this is k from 1 to infinity, and when limit n goes to infinity, this will be called a double integral. And the limit of the limit this over the region double integral of f of x comma y dA can be dx dy del x del y, that is dx dy or dy dx, isn't it? So this is the definitions coming up here. So this Riemann sum, and this is nothing but the volume is double integral f of x comma y dA, and this limits can be found by using the region on the xy plane. When you find the limit for x and y, you can first integrate with respect to x or with respect to y as the problem demands. If dA is dx dy, your inner integration is with respect to x. How the integration is performed? We know partial derivative of a function, which is calculated by holding one variable fixed and differentiating with the other variable, isn't it? In the similar way, let's consider the reverse process of partial integration. While integrating one variable, we consider the other variable constant. Right? This is the way we are going to proceed here. So formula is double integral, which has been defined in this way, question number 2. Now let us see the formula is given here, expressed as. So in this particular part, we have rectangular regions. That is, here the region in this graph is a non-rectangular region, isn't it? But the first part we are going to have the region on the ground xy plane is a rectangular plane. X and y both have constant limits. That's the first case we are discussing now, right? So Fubini's theorem says that when x is between a and b and y is between c and d, both are having constant limits. So in the x direction, in three-dimensional space, x is from a to b. X, this is the line x equal to a, this is line y equal to x equal to b, and this is y axis, this is x axis. Y is equal to c and y is equal to d. See, all four constants give you a rectangular surface, and the f of x y is a surface given here. So over this rectangular surface, we are going to find the volume bounded by this surface is that equal to f of x y. Simple. So when all the limits are constant, the dA can be either dx dy or dy dx. You can flip the integration. That is, if the limits of x are a and b, when x is inner integration, you can integrate with respect to first x and then substitute the limits of x a and b, and then the result can be integrated by further with respect to y, or you can reverse the integration order. This is dx dy first, now dy, but when you differentiate with respect to y, we remember the limit of y is c to d, so the integration gets a c to d. This is called inner integration. In the first iterative integration, we keep dx is constant. Wherever x comes, we will keep it constant, integrate with respect to only y. That's going to happen. And one more thing, I will show you a sample here. Double integral xy, very simple function, dx dy. X is from 0 to 1, y is from 1 to 2. So because how do you find this is limit of x? The inner integration is the dx. So the inner integration will have limits of x, and x is 0 to 1. So integrate it with respect to x. Keep the y constant. It will be x square over 2. We know how to integrate x. We have seen it in calculus 2. So x square y over 2. The limit of x is from 0 to 1. Keep the y constant. Now outer integration is from 1 to 2. dy is waiting for us. Now complete this one. It will be 1 over 2. So substitute upper limit 1. 1 square is 1. 1 over 2. Lower limit is 0. So keep the 1 over 2 constant outside. Now integrate y. What do you get? Y square over 2, and the limit is from 1 to 2. That is it. So when you substitute 2, so the answer we can simplify further. This is 1 over 2. This is y is 1 over 2. Again, denominator is constant. Keep it outside. Y square. 2 square is 4. Minus 1 square is 1. This is 3. The answer is 3 over 4. Isn't it? Okay. If you flip this limits, integrations, you get outer limit. When all the limits are constants, that means you are integrating the function over a rectangular region. You get here in the limits of y from 1 to 2, integrate with respect to y first, inner integral with respect to y. When outer integral with respect to x, the limits of x are 0 to 1. Still, first integration with respect to y, and then substitute the limits of y, and then integrate with respect to x. Till the answer will be same. Right? Okay, let's go with some more rules. When a constant is multiplied, you can keep the constant outside and carry on the integration. If two functions are added separately, you can integrate f with respect to x and y and g. Separate this function with integrations, or addition. This one is for subtraction, and this one is for this R region has been separated into two parts, region 1 and region 2. That's it. That's region 1 and region 2 case has been shown here. Now let's go to exercise set 14.1. The first problem is double integration e raised to x plus y dy dx. See, all the limits are constant. See, one more rule I will tell you. If you can separate the f of x comma y into the product of a function of x and a function of y, that is, if I write f of x is equal to x square y cube we can write, see, f of x y is equal to f of x is equal to x square, f of y is equal to y cube. We can separate as a product of two functions. One is function of x, one is function of y, isn't it? In such cases, we can separate the integration of x, the limit of x is a to b f of x dx, and multiply integral c to d, the limit of y, f of y dy. This is possible when you can separate the function as a product of two functions. One is function of x, another function of y. But if I give you f of x plus y, here the integration is separated by dot product isn't a multiplication. X plus y, you cannot multiply the two integrals, isn't it? So if I write double integral x plus y dx dy, you should separate as two different integrals, as two different double integrals. Double integral x dx dy plus double integral y dx dy. This is possible, otherwise straight away integrate this one. That is also possible. You cannot separate as product. Yes, so let's try this one. Problem number 5 first. Problem number 5. What is the first step? You can integrate. See, you can separate e raised to x as e raised to, e raised to x plus y can be written as e raised to x into e raised to y. This is f of x, this is f of y. So what I am going to do here, it is the limit of y is 0 to ln 3. Limit of x is 0 to ln 2. So here the inner integration is y. The limit of y is 0 to ln 2, and the outer integration is x. The limit of x is 0 to ln 3. So remember that inner integration takes its limit here. Okay, limit of y is 0 to ln 2. Okay, so I separate this one like this one. Integral 0 to ln 3, which is the limit of x. So e raised to x dx multiplied by another e raised to y dy 0 to ln 2. This is possible when you can separate this function as a product of two functions, x and y, a function of x and function of y, right? So integration, they are independent actually. Now integrate dx, integrate e power x. You will get e power x back, and from 0 to ln 3. Integrate e raised to y with respect to y, it's e raised to y 0 to ln 2. This is e raised to, first term, e raised to x will be replaced by ln 3. E raised to ln 3 minus e raised to 0 upper first term into multiplied by second term is e raised to ln 3 minus e raised to 0. The first term is 3 minus 1, 2. Second term is e raised to 3. E raised to ln 3. So this is ln 2. This is ln 2. Here it is ln 2. Remember it, is it? So e raised to ln 2 is second term, which is 2 minus 1. So 2 minus 1 is 1, 3 minus 2, 2. The answer is 2. So this is possible. We can directly integrate by first integrating e power. You remember a rule, e raised to ax plus b. When you integrate this one, the answer is e raised to ax plus b, and the coefficient of x will be in the denominator. That's the way to integrate exponentials. So when you directly integrate, y should be treated as a constant when you integrate with respect to x, or when you integrate with respect to y, x should be treated as constant. That's possible in any way. Let's go to problem number 9. Now we cannot separate this function as function of x and a function of y, isn't it? We should integrate it as it is Okay, first integration is with respect to y, and the limits of y are 0 and 1. This is inner integration. Okay, let's go ahead. There is y in the denominator. Y in the denominator. So when you want to differentiate with respect to y, you use substitution method. Okay, we first take this part, isn't it? Let u is xy plus 1. Therefore du with respect to y, because we are integrating with respect to y, the variable is y. Du by dy is x plus 0. Therefore du is x into dy. See, this x into dy becomes du, and the denominator will be u square. So integration inside this one, you can find the limits of u as well. When y is 0, what is u? U is 1. When y is 1, the upper limit of y, lower limit is 0, upper limit is 1. Upper limit 1. When y is 1, what is u? U is y is 1, x plus 1. U is x plus 1. Now the inner integral is done here. Integral 1 to x plus 1. The outer integral is remember it, 0 to 1. The inner integration is taking place here. X into dy will be du. So du over u square. The outer integration remains with respect to x. Now what is going on next? Integrate 1 over u square. We should remember u, it is u power minus 2. U power minus 2. So when you integrate u power minus 2, it will be u power minus 1 over minus 1. That is, I am writing directly, outer integration is 0 to 1. Inner integration becomes negative 1 over u, and the limits of u will be 1 to x plus 1, and the outer integration is with respect to x. Okay, and then we continue the next page. It will becomes outer integration is 0 to 1. Inner it will be minus is outside. Keep the negative outside. 1 over u, the upper limit is x plus 1. So 1 over x plus 1 minus 1 over 1. Upper limit of u is x plus 1. Lower limit of u is 1. And dx. So what is happening here? This will be positive. When you apply minus 1 inside, it will be 0 to 1. 1 minus 1 over x plus 1 dx. Now integrate with respect to x. What do you get? First you can separate 0 to 1 dx minus 0 to 1 dx over 1 plus x. So first one is x from 0 to 1 minus second one is ln x plus 1 from 0 to 1. Now substitute upper and lower limit. The first term becomes 1, second term becomes minus. When x is 0, ln 1 is 0, x is 1, ln 2. So ln 2 1 minus ln 2 will be the answer. Let's go for problem number 13 from the textbook. Okay. All the 3 problems in a row. Let me try here itself simply. Problem number 13. See, dA can be written as either dx dy or dy dx as you like, but the limit of x is given here from negative 1 to positive 1. The limit of y is from negative 2 to positive 2. So the order is important. You can choose the order. I am choosing it here. Integration 4xy cube dx dy. Isn't it? Okay, you can write dy dx, no issue, whatever the method you like. You can separate this function, gentlemen, because this function is separable. independent. So I can write this one. So double integral, isn't it? I can integrate the first integral 4x dx, and the limit of x is negative 1 to 1. Multiply by second integral. Second integral is limit of y is negative 2 to 2. It is y cube dy. This is separable, isn't it? Function of x, you can say 4x. 4 is constant, you can keep the 4 outside. So 4 outside, when you integrate x, it will be x square over 2, limit is negative 1 to 1. Second integration is y raised to 4 over 4 from minus 2 to 2. So apply the upper and lower limit. This problem, you get 0. You can check. This is for problem number 13. Problem number 15. Problem number 15. See, there is a function of x is given here, a function of x and y. Actually, you can write this one, f of x comma y, which is x into square root of 1 minus x square. So this is actually f of x, only x is involved. What is f of y? F of y is 1, so it is still separable. So what I am going to do here, write integration for y first. What is y? The limit of y is 2 to 3. 2 to 3, 1 time dy into limit of x is 0 to 1. So this is x times square root of 1 minus x square dx. That's multiplication of two integration now, isn't it? If the function is separable and independent. So when you can use substitution method for the second part, and first one will be integration y from 2 to 3 will be 2 minus 3, 3 minus 2, it will be 1. Second part you can use 0 to 1 x into square root of 1 minus x square dx. So this term becomes 1. You are worried about the now second term, isn't it? So let here, this is equation number 1. Let u is equal to 1 minus x square. Therefore du will be negative 2x dx. And find the limits of u. This is x is 0, gives u is 1. When you use x equal to 0 here, u will be 1. When x is 1, u will be 0. So now the limit for this term is, this term becomes u to the power 1 by 2 x and dx. See, x and dx will be du over negative 2, du over negative 2. So x and dx will be du over negative 2. Root of 1 minus x square will be root of u. It is u power 1 by 2. And the limit is from 1 to u, and u x is 0 to 1, so u is 1 to 0. Okay, let's do it. Therefore we are writing this one, integration, second part, first part integration, so on. Integration 1 to 0 u to the power half, which is root u du over negative 2, which is negative 1 by 2 is constant, u power 3 over 2 over 3 over 2, 3 over 2, limit is from 1 to 0. So I am completing this side, negative 1 by 2 outside. This is 2 over 3 when you invert this diameter. And upper limit is 0, so 0, lower limit is 1, so 1, negative 1. Negative will make everything positive, you get 1 over 3 is the answer. Problem number 16. I think we are almost ending here. Problem number 16. Here we cannot separate this one. We cannot separate the problem because x and y are mixed, isn't it? X, y, y sin x. We cannot write f of x and f of y. It's not possible. So you had to integrate one by one iteratively, right? The limits of, so dA can be dx dy or dy dx as you wish. We will take dA as dx dy. So inner integration is x is 0 to pi by 2. Outer integration is y is 0 to pi by 3. So let's write the formula first. Inner integration, outer integration is y, 0 to pi over 3. Inner integration is 0 to pi over 2. X sin y minus y sin x. See, this is dx dy. First integration is with respect to x, so keep y constant and then integrate. When you integrate this term, y is constant, so sin y remains as it is. Integration of x will be x square over 2, and the limit for x is 0 to pi by 2 sin y. See, let's write the sign at the end. I'm writing here, it is. I'm writing from here. Integral 0 to pi by 3 outside integral, integrate inside it. So x will be x square over 2 sin y remains minus y is a constant, integrate sin x, it will be minus cosine x. And now the limit is limit of x is 0 to pi by 2 dy remains, right? Okay, now substitute the upper and lower limit for x. Right here, I'm writing here. Outer integration is 0 to pi by 3. Now apply pi by 2 upper limit for x. X is pi by 2 square divided by 3. X square is divided by 2. So pi by 2 square divided by 2 sin y minus y, minus and minus, it will be plus cosine pi by 2. Cosine pi by 2 will be 0. Now we have to, and lower limit is what? Up minus, lower limit is 0. X 0, this time will be 0 when cosine is plus y into cosine 0 is 1. So lower limit should be carefully considered. That's it. We substitute outside dy. Simplify the term inside, which is the first term is pi square over 4 divided by 2 pi square over 8 sin y plus y this is 0, so minus y. So that's the term we are getting here. Integrate 0 to pi by 3 pi square over 8 sin y minus y dy. Just integrate this one. What do you get? Pi square over 8 is constant. When you integrate sin y, you will get minus cosine y minus y. When you integrate, it is y square over 2. Substitute the upper and lower limit from 0 to pi by 3. I leave this part to you. Substitute upper limit, cosine pi by 3 will be here, and this is pi by 3 whole square. Next, lower limit will give you cosine 0 is 1. Simplify. The answer is pi square divided by 144. Simplify and check the answer, right? Okay. Next, two more problems, I think. Here straight away you can integrate. This is z is a function of x and y, isn't it? So this is the term to be integrated. Double integral. You can write 3x cube plus 3x square y. You cannot separate into the product of two functions. One is function of x, another is function of y. It's not possible. So dx dy, you can write dx x is from 1 to 3. Outer integral y from 0 to 2. I'll leave the answer, this work to you, because the idea has been home by this time, I think. And the answer is in the PowerPoint. You can check the answer is coming around 172. Fine. The last problem, maybe the last problem next we are seeing. The volume of the first octant. Volume of the first octant bounded by the coordinate planes and the plane y equal to 4 and z. Actually, this is not clear here, isn't it? This is x over 3 plus z over 5 is equal to 1. This is the equation, isn't it? From this one we will find z. Z is the function of x and y, the roof of the volume, isn't it? So z is here z over 5 is 1 minus x over 3. So z is equal to 5 times 1 minus x over 3. This is the function to be integrated. So double integral 5 into 1 minus x over 3, we can write dx dy. You have the limit of z, y is 4. Is it upper limit or lower limit? You know, you are in the first octant. When you separate a cube into 8 equal parts, the one part in the positive quadrant, which is in which all the x, y, z will be positive values. So you start from x equal to 0. So actually this the surface, what they mean here is a three-dimensional space, and y is equal to 4 is a plane here, y equal to 4. So this is parallel to x-axis, xz plane, isn't it? And there is a plane like this. So we don't want the graph actually, but how to find the limit? Limit of y is 4, but the lower limit is 0, because we are in the first octant, all the y, x, y, z are positive. So y from 0 to 4. How do you find x? X is 0 to what? X is to be found from this equation number 1. Take z is 0. Z is 0 gives you on the ground, isn't it? You are on the xy plane. So when z is 0, you will find x value. X value will be 3 when z is 0. Z is 0 gives x is equal to 3. So the limit of x will be 0 to 3. Limit of y will be 0 to 4. This is enough to integrate this. Phi is constant, keep outside. Just iterate. This is a function of x, function of y is just 1. So we can separate. Okay, try this answer yourself. This is 30 cubic units. That's the end of this problem, this model. And in the next video we will see. Over non-rectangular integration of the surface over a non-rectangular region, where the region is non-rectangular, right? Okay, thank you very much.